So in this video, we will show how to represent a signed integer number using the one complement representation. So in the complement system, negative value are represented by some difference between a number and its base. Uh, the diminished radius complement of a non-zero number n in base r with d digits can be represented by r power d subtract 1 subtract n. Okay, we can see some representation way later on. This is much easier than the formula we have right here. In the binary system, this gives us a one complement and it's amount to little more than flipping the bit in a binary number. Okay, so that's the way how we the one complement representation will be represented. Here's a example. Let's say using a 8-bit one complement representation for the number positive 3. So basically, we just represent a number 3 using 8-bit. So that's the binary string. So so it means for the positive, we have the same with the binary string represent the number 3. Now, in order to represent the negative number 3, we just flip the bit of the number positive 3. So flipping the bit is mean 1 becomes 0, 1 becomes 0, and 0 become 1. Okay, so in order to represent the negative 3, we just represent the positive 3 and we flip the bit. So this one is the bit string represent the negative 3. Okay, so in one complement representation as with the sign magnitude, the negative value as indicated by a 1 in the high order bit right here. Okay, so basically this is the positive number and this is a negative number. The complement system are useful because they eliminate the need for subtraction. The difference of two values is found by adding the minus 1 to the complement of the subtrahend. Okay, here's an example how the one complement can be used to perform addition. So for example, we want to perform the addition of 48 and negative 19. Okay, so basically the first step we should note that the we first transform or convert the 48 into binary and negative 19 into binary using one complement representation. Okay, so we just discussed before with the positive number, the one complement representation is the same with the binary representation of the number. So 48 just represented by the number binary string right here. For the negative 19, so in order to find the one complement representation of negative 19, first of all, we need to find the binary representation of positive 19. Okay, so basically positive 19 can be represented by this binary string. So to get the one complement representation of negative 19, we just flip the bits of the bit string representing the positive 19. Okay, so this one we just flip the bit. 1 becomes 0, 1 becomes 0, 0 become 1, 0 become 1, 1 becomes 0, 0 become 1, 0 become 1, and 0 become 1. So this is the bit string represent the negative 19 in the one complement representation. Okay, so we just put right here, and for the subtraction right here, we just do the addition as the two number together. So we have 1 plus 0 plus 0 equals 0, 0 0 equals 0, 0 1 equal 1, 0 1 equal 1, 1 0 equal 1, 1 1 equal to 1 0. We write out 0 carry 1, and 1 0 1 equal to 1 0. We write out 0 and carry 1. 101 equal to 10, we have write out 0 and carry 1. So this is the last one, so we just wrap a carry around and put it into the last digit right here, and we add them up. Okay, so 1 right here, carry all the way out here, and we add to the last one. So 0 plus 1 equal 1, and all the other digits just copy to the result. So we have the 48 subtract 19 or plus with negative 19 equal to a 0 0 0 1 1 1 and 0 1. Okay, so that's the way we perform the calculation with the one complement representation. So although in the end the carry around adds some complexity, one complement is simpler than implement than the sign magnitude. But the one complement representation is still have the disadvantage of having two different representations for 0. We also have the positive 0 and also negative 0. So in order to overcome this disadvantage, we have the two complement representation. Okay, so basically the two complement is the radix complement of the binary numbering system and the radix complement of a non-zero number, and in base r with d digits is just represented by r power d subtract n. Okay, we can show later on how to represent a number in two complement representation.